Hello everyone. Today, welcome to you all to this amazing YouTube channel, Root Knowledge. Today, as I have said to you, we'll cover or we'll start with mechanical properties of solid of class 11. After completing the class 11, we'll jump on to class 12. So, what the topic says, rather further taking your time or wasting here and there, let's start with the topic. The first is that after catching up the topic, mechanical properties of solid, the first question which rises to your mind is what is solid? Solid is a type of matter, a state of a matter which you have already discussed or studied in class 9th and 10th. Means majorly three type of matters are there like solid, liquid and gas. So further in this chapter we'll discuss only about solids. So what is solids? Solids is nothing but a state of matter where atoms are so closely arranged that they have very high intermolecular force of attraction, right? They have also very structured type of structure, means very arranged structure, very fixed volume they have. They contain very high melting point and boiling point, right? So all these features which you have already covered or studied in class 9, 10, 10 basic, they are all basics. But the second thing is, after coming to the next topic, which is the first after coming into class 11, the first term which we used to have is elasticity. Elasticity is nothing but, so first of all the topic is elasticity. Elasticity is just a property, or you can say, or a tendency of an object or a material to regain its original shape or size after removing the force to an object, right? That property is called elasticity. I think if we'll compare to your childhood days, if you're remembering that nostalgic things, if you're a nostalgic person, so in your childhood you have already, means obviously you have once or many times you have played with rubber band, with pebbles, stretching or children's to all. So there, the rubber band which you stretch and it compresses, that property is called an elasticity. I think now it is clear to you all. Next, moving on to the stress. What is stress? If we'll talk about, or if you have heard already, you have heard in your daily basis that there are a lot of stress of studying, there are a lot of stress of covering the syllabus, going for the exam, attempting the paper, for the job, even for career options, and all many type of stress are there in your daily life. But rather comparing to its daily life, if we'll talk to our physics also, then they both are the same thing. If I'll say like what is stress? Stress is nothing but force per unit area. We'll say like force per unit area. Force is what we applied, and particular that area, the ratio of force upon area is called stress. And if I'll say that there are the SI unit of force is Newton and area is L square, so Newton meter minus 2 is a unit, right? After that, if we'll say like dimension of this, so what the dimension of force? Force the dimension of m l t minus 2 upon L square. So after getting the dimension, we'll say that ml minus 1 t minus 2 is the dimension of stress. I hope the second terminology stress is clear to you all. And after moving to strain is also the same thing, right? Not the same thing exactly, but it is it is defined as a elongation or compression in the length which we used to have after applying force to any object, and then total length of that original length of that object. This is the formula of strain. This is dimensionless quantity, okay, because the both have the same dimension, so they will cut to each other, and this is a dimensionless quantity. And if I'll say the very basic question which people cannot say or answer to anyone, is that what is the difference between stress and strain? Stress is a restoring force which an object exert after applying the force to it. Like as we say that after applying to the force to an object, means after applying external force to any material, the property or the tendency to restore the that structure to regain its shape, it also applies in against force, and that against force or restoring force is called stress, right? But the strain is nothing. Strain is not like that. Strain is a change in that material, whatever the change, like in length. So if it taking the change in length, we'll say it a longitudinal strain, then lateral strain. That depends upon how the change happen in that material. But the change the change which occurs is called that strain. Stress is a force, but strain is an change in an object or a material. I think these four terminology is clear to you all. Plasticity is nothing but an opposite terminology which is used for the elasticity. Elasticity have the property to regain its shape. They can compress, they can stretch up, but plastic doesn't have us like that. Means they have very fixed type of crystals and atoms and such that they have very high intermolecular force of attraction between them, so they cannot move it so easily, right? So that nature is called a plastic nature, right? So I think all these four terminology is clear to you all. Now moving on to the Hooke's law. What is Hooke's law? Hooke's law says that, if I used to explain to you all, Hooke's law says that stress is directly proportional to strain. Am I correct? No, not like that. This is incomplete definition. At a particular up to a particular limit, up to a particular limit only. This is a complete definition. Hooke's law means Hooke's a scientist name, and he has researched to this solids, and then he has found a relation between a stress and a strain, and he has said that whatever force you are applying to an object, and it is restoring it is also applying and restoring force to that is directly proportional to the change in an material. But as we know that every material has its own limit of elongation or compression or restore its shape and size, so it depend upon that limit. And if I say he has drawn a graph which we used to say stress strain graph, right? So it'll say it is directly proportional, but up to limit, after that it is not proportional at all. So this is a stress strain graph where this is stress is proportional to strain, as you know, but up to that limit, after that it is not following the same rule, because that property are not yet have lost the property, that object have lost the you have lost the periods of that limit to cross across the structure. Means that the property, the object now have a limited limit to cover the stress and strain graph. After moving towards after the limit, it have lost the property to regain its shape, and that is called the property, or you can say the limit of an object, right? I think that the stress strain curve is clear. Hooke's law is also clear. Now moving to the type of strain. What is strain? You have already cleared about it. Strain is basically of two types: longitudinal strain and first is longitudinal strain and second is tangential strain, right? Stress, sorry, this is the quantity of stress. Even stress and strain are both the same thing, longitudinal stress and the tangential stress. Then again longitudinal is divided into what type of, means are you compressing it, compressive you can write, or you can say tensile, I mean if you are providing tension to it. Compressing it means like compressing an object, and provide tension to it is like forcing an object or pushing an object to it, right? So this is of two types, longitudinal stress. And second is tangential stress, means at a particular tangent, through any tangent of an object you are applying the force to it, right? So the formula will remain the same, sigma, which will say is stress, force per unit area, right? This is the formula, and this is the same to all. But in tension, the length will change. So rather than we'll say sigma is equal to tension per unit area. Tension is also a type of force, right? So that is clear, I think, to you all. Then moving on to the next topic, modulus of rigidity. What is modulus of rigidity? We'll say modulus of rigidity to an, or also a modulus of elasticity. It is majorly of three types. If we'll say here modulus of rigidity or elasticity, so it is basically of three types, right? First is Young modulus, second is shear modulus, and third is bulk modulus. This is a property, or बोल सकते हैं, this is a modulus of rigidity, which is of three types, Young modulus, shear modulus, bulk modulus. It is denoted by Y, it is denoted by eta, and it is denoted by B. ठीक. अब it depends upon how you are applying the force. Means that if the body is absolutely solid, then there will property and the change occurs in a length, means in the contraction in length or in elongation in length, then we'll use here the Y term, and the formula is equal to, means the formula is majorly the formula, or you can say a definition of Young modulus is stress upon strain. Simple. Young modulus is defined as stress upon strain, and stress we can write F by A, and strain we can write change in length upon total length. So on arranging we get this is the formula of Young modulus. After coming to the shear modulus, shear is a type of theta. You means like some tangential or type of tangential force you are applying to it, and that type of modulus or that type of object where we use shear modulus, so it is denoted by eta, or you can say, means in all the books or in NCERT also it has mentioned with eta only, so I am using the same thing. It also, shear modulus is also a stress upon strain. Stress here the same thing, force per unit area, but strain means let's suppose an object is there, right? It's a cube, let's consider. You are applying a tangential force to it, and it is changing in theta angle, right? If you are taking a cylinder, as already you have taken seen in your kitchen or somewhere in your house, so you have seen after pushing it to a tangential, it rotates into a theta angle. That change in the length or that change in the theta is called, denoted as theta in shear modulus. I think now it is clear, right? Now moving on to the next is bulk modulus. Bulk means bulky type. You have already heard bulky nature or bulky type. So bulk modulus is denoted by B, and the formula is pressure, because here we use this modulus of rigidity especially for in a liquid or for a liquid. So pressure is a p-axis upon change in volume, right? Pressure is what? Force upon area. It's the same thing. Pressure is the same thing. Now pressure is equal to force upon area, and the volume was also in change. When an object on applying an external force, there occurs change in volume, means an object get changes through the volume. That property where we that there we use the modulus of rigidity as a bulk modulus. In हिंदी फिर से अगर किसी ऑब्जेक्ट में चेंज हो रहा हो सॉलिड तरीके से, मतलब सॉलिडली, अगर कोई ऑब्जेक्ट सॉलिड है उस पर आप फोर्स लगा रहे हो तो हम यूज़ करेंगे शेयर मॉडुलस। मींस अगर सिंपल फोर्स लगा रहे हो, अगर आप किसी पर्टिकुलर थीटा एंगल पे लगा रहे हो तो वहाँ पे हम यूज़ करेंगे शेयर मॉडुलस। और अगर आप किसी लिक्विड ऑब्जेक्ट पे, लाइक कोई कंटेनर है उस पर पिस्टन लगा है, उसके ऊपर प्रेशर मार रहे हो, प्रेशर लगा रहे हो एक्सटर्नल फोर्स के थ्रू, तो वहाँ पे हम यूज़ करेंगे बल्क मॉडुलस। आई थिंक दीज 3 टर्म्स आर क्लियर टू यू ऑल। नाउ मूविंग ऑन टू द लास्ट सेकेंड टॉपिक of today's video is Poisson's ratio. This last second topic is Poisson's ratio, and after that we'll cover energy stored, means elastic potential energy after stretching the wire, what type of energy it is stored in that. So we'll cover these topics today, and tomorrow we'll completely discuss the PYQs, previous year question paper of JEE Mains, NEET, even of boards. So that tomorrow's session will be a fully packed practice session. I think it will be beneficial to you all, so we'll say it tomorrow. But now covering on to the last second topic, which is Poisson's ratio. So after reaching to Poisson's ratio, before that we should be aware of the 2 terms. First is lateral strain, second is longitudinal strain. Type of strain they are both. So what is lateral strain? The strain which is perpendicular to the applied force, means a type of strain or a change to a material if you applied a force perpendicular, means a perpendicular change in the material after applying the force is called the lateral change, and the longitudinal change in the material or longitudinal strain, that will called as longitudinal strain, right? So I think the both terms are clear to you all, right? So moving on the Poisson's ratio. Poisson's ratio is denoted by sigma, and it is the formula of delta L by L, right? It is denoted by sigma, and the formula of Poisson's ratio is this. This is a ratio of lateral strain of a material upon longitudinal strain. Means if you are applying a force to any object, then what about how the strain, how the perpendicular diameter of a wire or diameter type of radius things are changing, means the internal change of an object upon the longitudinal change of the material is called the Poisson's ratio. I think clear to you all. Now moving the 2 things which are mentioned in NCERT and I think is beneficial, even it came to the JEE Main exam once. So this is the value of Poisson's ratio. The value of Poisson's ratio for steel is between 0.28 to 0.30, and for aluminium oil it is 0.33. Means for aluminium it is for 0.33 up to mark. So remember it, maybe I'll ask in some previous year or next year. So this is a thing. And then now moving on to the last topic is elastic potential energy in an stretched wire, which we have discussed. So energy stored or elastic potential energy. Which is denoted by U. Let's suppose you are taking a wire, right? Let's suppose this is a wire, right? This is a wire of length L and area is A. Tick. We are taking area A and length is L. After applying force to it, the value become Y as a Young modulus. A is an area upon the change in length. Let's suppose the change it occurs delta L, right? Something like that. You are stretching it up. So this change is delta L. The formula become delta L by original length L. So this is a force. We are going to find out the potential energy, which is equal to the work done by external agent, right? So what is the formula of work done? As we know, that force into displacement, but here we are considering it a small, infinitely small change, so here we'll mention it dl. What is force? Force is YA into delta L by L into dl. So this is a small change, but rather if we'll say that we have to, for a small change we have mentioned it dl, but for a long change, for a long term, means for whole object, to find the potential energy, we will integrate it both side, right? So W is equal to, we are integrating from 0, means from 0 to all, from 0 to the length L, Y A, change in length upon total length into dl, right? So on integrating, it will become AL, right? After integrating it directly we will get this, and if you are not able to understand, I'll write one more step, YL into L square by L, right? L the same thing, change in length or denoted by small l or capital L, you will say. So this is the same length, same thing, I think, right? So this is a work done. After that we'll get the thing, and which we used to say that this is Y Young modulus, this is delta L by L ka whole square, so this is strain square into area into length is volume, right? So this is the formula of work done external, which is equal to potential energy, which on further reducing it will say U is equal to half stress into strain into volume, right? If you're confused with how we have changed stress into strain, so what is the formula of Young modulus? FL by A into delta L, right? So F by A is known as stress and this is called the strain, right? So after putting the value, one strain is cancelled by one another one, so we'll get the this formula, right? Yes. So this is the ultimate formula, which will denote in a short form like this. Also, this is a very important formula where we get this question in JEE Main every year. Means I have studied and I have gone through the papers. This is a very important formula in the whole chapter. So the whole chapter of mechanical properties of solids is already covered in the whole video. So I think it is clear to you all. If you have any doubt regarding any topic of this chapter, you can comment box in the video. I'll definitely answer the question, and tomorrow we'll discuss the practice problems of even SCVL use and previous year question paper of NEET, JEE Main and IISER. So all the best for today and enjoy your day. Thank you.